All right, here we go. So we started the rest of 10-4 yesterday. Today we're going to do the rest of 10-4, and then likely we'll even on to 10-2, because it's really not that difficult to finish up 10-4. We did one problem already. Yesterday we talked about the discriminant. And remember that the discriminant is really just part of the quadratic formula. Just part of the quadratic formula. It's a very important piece. It tells me how many real solutions I have. How many real solutions I have. It also gives me a picture of what the graph is kind of going to look like. So, let's start off with number 2. Right away, we remember that the formula for the discriminant is b squared minus 4ac. No square root. No square root. Just b squared minus 4ac. We need to identify what's the a, the b, and the c. But first, make sure that it's equal to 0. Is it? Yes. It is. So now we just need to plug it in. That being the whatever the variables are. A is equal to 5. B is equal to -3. And C is equal to 8. So now we plug it in. Remember to use parentheses here. -3 squared minus 4 times A is 5, C is 8. And just to make sure that I do get the correct answer, I'll use a calculator. It's a good idea. I might make a mistake if I don't. So, parenthesis, -3 squared minus 4 times 5 times 8. And I get -151. So, this is the value of my discriminant. It asked me to find the value, so this is part of the answer. Make sure that you answer the questions. Then it asks to determine how many real roots there are for this quadratic equation. How many real roots? If it's a negative, let's go back to our little cheat sheet up here.
0.
If the discriminant is less than 0,
0
0 real
real roots.
roots. 0 real roots. Now, I hope none of you would say, I'm just going to box -151 and box 0. If you box -151 and box 0, I don't know which one's supposed to be your discriminant.
Well, there's only 3 different discriminants, and 151 doesn't.
Yeah, and 151 doesn't really make sense for the number of real roots, but do make sure that you at least tell me how many real roots there are. And that is to say, 0 real roots. All right, why don't you go ahead and do number 3 on your own? Go ahead and do number 3 on your own. I don't think this would be too difficult for you to do. So go ahead and raise your hand if you need a calculator. I just seriously for whatever. Thank you, man. Really. Did you get it? What'd you do? All right. I'll start to put down what A is, what B is, what C is. Don't worry, I won't plug it in right away. A equals 2. B equals 11. C equals 15. Some pretty big numbers. B squared. 11 squared. Minus 4 times 2.
It's not 2, it's 11.
Times 15 should be plugged in looking something like this. 11 squared minus 4 times 2 times 15. We got, I got 1. So 1 is the value of the discriminant. So how many real roots do we have if 1 is the value of the discriminant? That's a positive number, right? It's bigger than 0. So it will cross the x-axis more than one time. The answer is 2 real roots. So this is definitely a time where you want to say that there are 2 real roots, and not just circle 2. Otherwise, I don't know if you're talking about 1 real root and 2 is the value of the discriminant, or 1 is the value of the discriminant and there's 2 real roots. All right. I think you're good with the discriminant. I'm going to now go on to 10.2. So we're going to back up a little bit, and we're going to go to 10.2. So we're backing up to 10.2. This is where you should be right now. We need to kind of define some vocabulary here. What is a root? The root is actually the solution to a quadratic equation. The root is the solution to a quadratic equation. We just got done finding the value of the roots by using the quadratic formula. So we did it in 10.4. Remember the song. Don't make me sing it, right? Don't make me sing it. So that's the solution, the root. They're interchangeable. The answers. The zeros are the x-intercepts of the quadratic equation, or a quadratic function, I'll say. The x-intercepts of the quadratic function. I'll tell you right now that these two things, roots and zeros, are almost going to be pretty much interchangeable. That is, that you can replace roots with 0 and 0 with root and basically be talking about the same thing. In other words, when we graph the quadratic equation, wherever it crosses the x-axis, wherever it crosses, ends up being the answers to the quadratic equation, the solutions, the x values. So this is another way of basically finding out what the answer is. Let's go to this example. It says solve, and we have x squared plus 6x minus 7 equals 0. I'm going to, off to the side here, remind you how you can solve it by factoring. There's lots of different ways to solve quadratic equations. I'll remind you how to solve a quadratic equation by factoring. So let's rewind a little bit. Rewind a little bit. Solving something like this, we would need to set it equal to 0. Right? It is. And it's a trinomial. No greatest common factor that can be taken out of it. So being a trinomial, we put down x here, x there. That'll give me x times x, that's x squared. Two numbers that will multiply to negative 7 that will add to 6.
7 or negative something and 1.
Yeah, it is something with negative 1. I'm thinking it's actually going to be positive 7, negative 1. Now let's just double check and make sure. The outside plus the inside should give me that 6x, and negative 1x plus 6 or 7x does give me 6x. So if I FOIL this, would go get me right back to this quadratic equation. Then we set those things equal to 0 and solve, right? So we'll set x plus 7 equal to 0, x minus 1 equal to 0, and solve. X equals negative 7, and x equals 1. 2 answers? This is one way to be able to find out what the answers are. In other words, I should be seeing, when I graph this, over here, I should be seeing it cross at -7 and at +1. Well, let's graph it. Make sure that really is the case. Well, remember, the first thing that you like to do when you're graphing is find out where it's being cut in half. So we can find our vertex, where it starts. So we need to plug in the opposite of B divided by 2A to find my axis of symmetry. We already have A, B, and C. So B in this problem is 6, so the opposite, -6. Divided by 2 times 1, so -6/2, or you're right, -3. So if the axis of symmetry is -3, I can go to -3 on this and put a dotted line. This is going to cut my parabola in half. This is going to find where the line that cuts it in half. This is the axis of symmetry, it's called. And it's somewhere on this line is going to be my vertex. Somewhere on it. So then I go and I'm like, all right, well, I'm going to plug in -3 into my equation, find out what it equals. I'll make a little table, x and y, and plug these values in. So I'll start with, though, -3. You're going to realize pretty quickly this isn't going to be very helpful, but -3, let's plug it in. That's -3 squared plus 6 times -3 minus 7. What do we get when we plug in -3? Well, let's go to our calculator and actually plug it in. -3 squared plus 6 times -3 minus 7. Uh-oh. I get a number that goes off my graph a little bit. -16. Now, it's not way off my graph, so I'm not going to likely think, I'm going to go by 2's here or anything like that. I think I'm just going to leave it, but I'm not going to actually plot that point. So it's somewhere down here, but I know it's -16. Let's plug in -2. See if it gets us closer. Plugging in now, -2. Nice thing is I can just go back and plug in 2 in place I had the 3's. And we get -15. Not quite getting there.
You gotta go the other way.
How about -1? No, we're not going to be able to go the other way.
We circle back around all of the numbers.
Let's try -1. That's close. -12. And 0. Well, 0 is nice and easy. When I plug in 0, what do I get? Because I don't even need a calculator for that part. I get -7. So 0, -7. I finally have a point that I can actually graph. So 0, -7. The nice thing is that if I have this point, I also have another point equidistant away from the axis of symmetry. So 1, 2, 3 away here, 1, 2, 3 away there.
Oh, yeah.
Then let's plug in 1. What do I get when I plug in 1 here? 1 squared plus 6 times 1 minus 7. I get 0. I have the point 1, 0. That's interesting.
Since when?
And it has to be equidistance away, right? 1, 2, 3, 4 for the other side. 1, 2, 3, 4. Interesting.
Is it because our bottommost graph is off the grid?
No, it's fine. It's graphed kind of like this for now. What happens when I plug in 2?
You're gonna get 2, 1.
Are you sure? Let's see. 2 squared plus 6 times 2 minus 7. That's 4 plus 12
Oh no.
minus 7.
You're gonna get 4. Or 5.
Yeah, I'm starting to think. Let's see. These sounds like you're saying lots of different numbers. Let's see. 2. Delete 2. I get 9. 2, 9. Right 2, up 9. Point equidistant away. Now, just because we don't have it fit entirely doesn't mean that we won't be able to see what the answer ends up being. And remember now, we just got done saying the answer is where it crosses the x-axis. Did we get the same answers as we got over here? Over here, remember, we had -7 and 1. Is this parabola crossing at -7 and at +1?
Yeah.
Yeah. That's the main idea here. We see right here at -7 on the x-axis, it's crossing. At 1, it's crossing. We get the same answer as if we were to just simply factor it. Now, some of you are thinking, I know you're thinking, you're like, well, Mr. Saldana, isn't this just way easier than graphing? Well, the only problem with that is, what if it's not factorable? Right? What if it's not factorable? Well, then you can't set them just equal to 0 in 2 different ways and solve, right? So we have to find a different way. That's why we have this graphing technique here. We have other ways of being able to do the same type of stuff. Why don't you take a look at the next one? Let's take a look at the next one.
It's not factorable.
You say it's not factorable?
Kidding.
Yeah, it kind of is. Kind of is. But you know what? We're actually going to skip this one. I want to go to the next one down here. I want to make sure that I go through a couple of different examples. Since quadratic equations also have 2 roots, but they are not always 2 different numbers. When the 2 roots are the same number, it's called a double root. Let's take a look at this example right here. First off, what's wrong with it?
It's not equal to 0.
Not equal to 0. We need to get equal to 0 first. So we move the 4 to the other side. We get b squared plus 4b plus 4 equals 0.
Do we add the b's together?
Well, we're going to do, can't add these b's together. Nope. We got to do the opposite of b divided by 2a. The opposite of b is 4. The opposite of that is -4. Divided by 2a, that's 2 times 1. So we get -2. -2. So you put an axis of symmetry at -2. This is going to cut my parabola in half. So we go to x and y, and we plug in first -2 to see where the vertex is located. What happens when I plug in -2? Well, that's -2 in parentheses squared plus 4 times -2 plus 4. What do we get? This is an interesting one. You guys all have calculators. What do you get? 0. You get 0. You end up getting 0. Interesting. We already have the solution. We already have the answer. Well, let's just plug in -1 and see what happens. Well, -1 squared plus 4 times -1 plus 4.
0.
No, not quite. 1 minus 4 is -3. Plus 4 is 1. So we got the point -1, 1. Which means we have a point equidistant away from the axis of symmetry. Okay, let's plug in 0. This one's nice and easy. We don't need a calculator for this. 0 squared plus 4 times 0 plus 4 equals 4. I seem a little tired today.
Yeah.
And let's just do one more point, see if it fits. 1 squared plus 4 times 1 plus 4. This one is, looks like 1 plus 4 is 5, plus 4 is 9. 1, 9. Oh, yeah. And we just connect the dots. Remember that this doesn't make a V, it's curved a little bit. But notice it does touch the x-axis barely at -2. For this problem, we end up getting an answer of just 1. It's a double root. Not x, sorry. This is going to be b is equal to -2. Final answer. Let's go to another example. Let's go to another example here. We'll do this one and then we'll be done. So no real roots. Let's solve this one. Let's wrap this one. We have, first off, the opposite of b divided by 2. A. It's -2 over 2 times 1. We get -1 as our axis of symmetry. So we have our line, our axis of symmetry at -1. That means that we're going to use that point to find out where the vertex is, where it begins. So x here, y here, -1 is what we're going to plug in. So -1 squared plus 2 times -1 plus 3. And you end up with, at this point, -1, 2. So left 1 up 2. Okay, so then you plug a point close to that, 0. 0 is what's squared, plus 2 times 0 plus 3 equals 3. 0, 3. Uh-oh. I get the feeling this isn't going to come anywhere near my x-axis. So then I plug in 1. 1 squared plus 2 times 1 plus 3, and we get the point 1, 6. Right 1 up 6. Points equidistant away on the other side. What do you think the answer is for this guy? Exactly. No real roots. No real solutions. It doesn't cross the x-axis. It never touches it. It doesn't even come anywhere near the x-axis. So it doesn't. You're thinking of like the vertex. That doesn't mean that that's the answer. So we'll stop there, and we'll go back to this tomorrow.